Right, here's section 1.2, day 2. We are now exploring the concept of even versus odd functions. Having conversations with you guys in class, I think you talked a little bit about even or odd polynomial behaviors when you're in your polynomial section last year in Algebra 2. It's not exactly the same thing as an even or odd function. So for even functions, they have to be symmetric with respect to the y-axis, and odd functions are symmetric across the origin, or with respect to the origin. So some of you guys are saying, well, I've got an even function, this one here, our basic parabola, that is an even function because it is symmetrical across the y-axis. But if you shift that y over, and say make it x minus 3, well, let's make it x plus 3 squared, and I shifted it over here, it's still 2, so you want to say it's an even function because it's squared, but are we still, now at this point, symmetric across the y-axis? We're not. So the degree up here does not tell us whether we're even or odd, as much as I wish it would. The parent function, it tells us whether the parent function that's centered at the origin is even or odd, but it doesn't tell us whether all quadratics are even or odd, or all cubics are even or odd. So we have a test for it. We're going to plug in f of negative x. If I plug in negative x into my function and I get back out f of x, then it is even. If I plug in negative x into my function, and I get minus f of x, then it's odd. And if I plug in negative x and I don't get back f of x or minus f of x, then it's none of the above. So let's see what that looks like in action. Here we have for 6a, it says graph each function. I don't have my graphing calculator pulled up, but this is a rational function. And what I want us to do is to, in class, we're going to look at it on our calculators and decide whether it's even, odd, or neither, and then test it. But for this video's sake, I just want to confirm it algebraically. So for this test, for even or odd or neither, you're just going to plug in negative x everywhere you see x. So for this one, I'm going to plug in negative x down here. And then I'm going to see what that boils down to. So I've got 2 on the top. On the bottom, I've got negative x times negative x. That's a positive x squared. So if I ended up with what I had before, so if f of negative x spits out the original function f of x, then we know this is an even function. So this is an example of an even function. When you put in negative x, if it spits back out the original function, then you have an even function. So let's look at our next example. Here we have g of x. This time I'm going to plug in it. We are always plugging in negative x. If I plug in negative x, I've got 4 times the square root of negative x. Can I just take that negative outside of the square root sign? No. So this is not giving me back g of x. It's not giving me back minus g of x. In other words, this here is not giving me this guy back. So not even. For it to be odd, it would have to give me minus g of x. This guy is, and so that would be minus 4 times the square root of x. It's not giving me that back either, so it's not odd. So if we're not getting back even and we're not getting back odd, this is neither. None of the above. It's not even, it's not even, and it's not odd. It's none. All right, so let's look at 6c. Again, our test is to put in h of negative x and see what gets spit out. So I've got negative x to the 5th minus 2 times x cubed minus x. All right, so negative times negative is positive, times negative is negative, times negative is positive, times negative is negative. Hopefully you know now if you've got something negative raised to the 5th power, that's going to stay negative. I forgot my negative sign there. For this negative x cubed, again, I've got a negative raised to an odd power, so it's going to stay negative. So negative x times negative x is positive x squared, times another x is negative x cubed. So this is negative 2 times negative x cubed. That's what it said before. All right, and then I have minus x. But what happens when I multiply the negative 2 times that negative x cubed? Guess what my problem here was? It should be this guy here. This is what I should have written, negative x cubed. And then when we evaluate that one, it's negative x times negative x times negative x, and that's negative x cubed. Now when we get down to this part, I've got negative 2 times negative x cubed. So this is negative x to the 5th plus 2x cubed minus x. So this is what it spit out. Is that the same thing as h of x? No, because h of x would have positive, negative, positive, and I've got negative, positive, negative. So not even. So then the other option would be, it would be minus h of x. So let's see what minus h of x looks like. It's minus times everything in here. Some of you probably now are already seeing it, but if I distribute this negative sign, I'd have negative x to the 5th. Minus times a minus is positive 2x cubed. Negative times positive is negative x. Is that what we have down here? It is. So this would be an example of an odd function. So again, going through the process here, we always plug in negative x. If when we plug in negative x, we end up with h of x, then it's even. If when I put in my negative x, I end up with the same thing as negative h of x, then it's an odd. And if it's not h of x and it's not negative h of x, then it's none of the above. So those are our 3 examples about even and odd functions. Good luck with your homework. Let me know if you have questions. Feel free to send me emails through Canvas.